Hello all, welcome back to my session. I think today, as a part of our DBMS training, today we continue with the normalization 2. In the last session, we discussed what is normalization, what are the advantages of normalization, what is the need of normalization, and we discussed what is first normal form. If you have any queries up to now sessions, please comment me. How to comment to me? Yeah, first you subscribe Easy BTech channel. If you subscribe Easy BTech channel, you will get all the notifications regarding your BTech subjects, and you can get updates, and as well as if you comment to me if you have any doubts. Okay. Please subscribe Easy BTech channel. Okay. Yeah, last class we discussed about what is normalization. What is normalization? Normalization is a process of decomposition of the data. What is the decomposition of the data? Decomposition of the database. What is the decomposition? Decomposition is nothing but we are dividing the table. Suppose if we have a table with some 10 attributes, we have a database with the 10 attributes. We are dividing into subparts. Okay, when we are dividing into why we are dividing into subparts? First one is to avoid the redundancy, and second one is to perform the lossless decomposition, and also we are checking the insert anonymous, update anonymous, and delete anonymous. Okay, already we discussed what about these things in the previous session. Please go through that my previous session, introduction to normalization, and if you have any queries, please let me know. Okay, now we continue with just I am giving what is first normal form definition, then directly I will move to second normal form. Okay, what is the first normal form? First, here it is the user. Based on the existing data model, you are creating a database. Okay, based upon your data and based upon your requirement, the DBA database administrator first create a database. Okay, once we have to create a database, okay, we have a lot of redundancies, and we have anonymous. Okay, insert, delete, and update. To overcome all the problem, data is created without duplications. We go with all the transformations. Means here we have a total 5 transformations. Each level is called as a one normal form. Okay, first normal form we perform one transformation. Second normal form we go with another transformation. Okay, I think last session we discussed about some functional dependency, partial dependency, transfer dependency, all the definitions also. Okay, first of all, first they are creating a database. I want to create a database, an employee database. Okay, I am a client. Okay, I want okay, I have one company. I wanted to create a database. Database is nothing but website. In the website, automatically you have to create a database. Otherwise, if you take any shopping mall, okay, you are creating a database. How to create a database? First, you create a database. Okay, suppose what about today customer DMart? If you take DMart, 1 minute. Okay, suppose DMart. Okay, suppose transaction ID and item name, like that you are creating. Okay, date, price, like that. When we create a database based upon the based on the client requirement, we create a database. Okay, sometimes the values may be dependent on one value is dependent upon another value. Okay, some values are repeated. Okay, suppose transaction ID is nothing but my transaction ID is 123. Okay, item is, okay, first I took some grocery items. Okay, suppose some $2 first rice. Okay, some date, today's date 5th 02, price around 50 rupees. Again around in the total 11 items or 10 items I purchased. Okay, sugar that is on cage rate 0502. Okay, some 40 rupees like that. Okay, only one person around transaction ID is 123, it repeated 10 times. To overcome this problem, we divided into decomposed into a table. How to decompose into table? The best way we are doing that process is called as a normalization. I hope you understood what is the normalization. Okay, once we create a database, this is the UNF. Okay, nothing but this is unnormalized format. Okay, to overcome this problem, we have to perform remove the repeating group. Remove the repeating group is nothing but, okay, now, okay, we are dividing 123. How many items I purchased? Total 11 items. Okay, 11 times. Okay, 11 times date and some transaction ID. Transaction ID is repeating. To overcome this problem, we dividing into two tables. Okay, this is called as a dividing. Okay, repeating. Okay, when we are dividing, okay, transaction ID in one table and date one table. Another one is some item and price and transaction ID. Enough. Okay, just only here we have to write transaction ID and date. Best way, which is the best way, based on that we can divide it. Okay, this process is called as normalization. Okay, here first normal form. What is the first normal form? Already we discussed about what is the first normal form. Remove the partial functional dependency. Okay, remove the repeated group, remove the partial dependency. Remove the partial dependency means, okay, one value is dependent upon only one atomic. Okay, actually first of all, remove the repeatancy of group is a first normal form. If a relationship is a first normal form, remove the repeating group. Okay, each and every value. Okay, the value is dependent upon the, okay, only one variable is dependent upon the only one thing. Okay, one variable. Okay, one attribute is dependent upon the, it not having multi-value attributes, and also the first aim in the first normal form is the value. What about the value? Okay, transaction ID rice. Okay, here I am writing 123. Transaction is 123. Okay, I am writing what are the items he took? Rice, sugar, soaps. Okay, some dal. Okay, different dals, and some honey. Like that, you are writing total 11 items. Only this is called as a atomic. Okay, the particular transaction having multiple values. To overcome this, we are writing some 123 in total, some 11 transactions. Okay, the value is repeating. To overcome this, we are dividing. The first normal form is nothing but each and every table consists of only atomic value. Atomic value is nothing but each and row having only atomic value. Atomic value is nothing but single value. This transaction is repeating more than one value. Okay, that's why to overcome this, we are dividing into table two parts. How to dividing in the table two parts? Transaction ID, date is one table, one relationship, and item, price, and transaction ID is the another table. Okay, if we are creating like this, this is called as a first normal form. Okay, then we go with the second normal form. Okay, second normal form. What is the second normal form? Second normal form is nothing but if a relationship in the second normal form, okay, it has no functional dependency. Okay, first of all, non-key attribute fully functional depend upon a primary key. Okay, what is the functional dependency and what is the partial dependency? What is the prime attribute dependency and what is non-prime attribute? First, we discussed about these basic things. Okay, prime attribute. Prime attribute is nothing but an attribute which is a part of candidate key. What is a candidate key? Okay, integrity constraints concept. I am explaining about the concepts. Okay, data model 3. Okay, if you want to know about what are the types of keys in DBMS, please check my previous video, that is data model 3. In the data model 3, we have a concept is called as integrity constraints. In the integrity constraints, I am explaining what are the types of key. Candidate key. What is a candidate key? Candidate key is nothing but combination of some primary key and another key value. Okay, a primary key with another non-key attribute is called as a candidate key. Okay, suppose if you take some student table. Okay, in the student table, in the exam. Okay, suppose if you are appearing for your exam somewhere. Okay, student number, student ID, and some paper ID. Based on these things only we can identify the subject. Why? Because here the particular student is registered. Suppose if you are in the CSC second semester, for second year or third year, okay, you have a subjects. What are the subjects? DBMS, Java, and some CO. Okay, you are registered for these subjects. Okay, I want to know about, okay, today what about exam? Which exam today? Student ID. Okay, here we have a course ID. Okay, based on these things only today he has some DBMS exam. Okay, here we have a course IDs also. For example, 101 is 101D is a course ID of DBMS. 102 or 101 Java is a course ID of Java. 101 some C. 101 CO is a course ID of CO. Okay. Here based on the course ID only we can identify the particular student can write today he's write some DBMS exam. Okay, means this is called as a candidate key. Candidate key is nothing but a primary key and another key, non-key attribute. Combination of these is called as a candidate key. Okay, here prime attribute, an attribute which is a part of the candidate key is known as a prime attribute. Here we are calling, these are called as a prime attribute. Student ID and course ID is a prime attribute. Non-prime attribute, an attribute which is not part of a primary key. Suppose in this example we have a student ID, some course ID, student name, S name, then course name and fee, like that. Okay, here student name and course name, okay, and fee, exam fee, all are called as a non-prime attributes. Okay, only these are called as a prime attributes, remaining all are called as a non-prime attributes. Why? Because these are not part of the candidate key. Suppose I want to know about student. Based on the student ID I can identify the student number. Okay, based on the course ID I can identify the course name. But I want to know about the fee of the exam fee. Okay, I want to know about the exam fee. Okay, each and every subject has depend upon the different fee. Some Java exam fee, some 1,000 rupees, for DBMS 800, CO around some 600. Okay, based on the course ID and student ID only we know okay, this particular student can pay, I think he should pay around, he registered for 3 subjects, 1,000 rupees, 800 rupees and 600 rupees. Total he would like to pay only 2,400. One student registered only for DBMS and Java. Then we have to know the particular student. Suppose student number 501. Okay, course ID 101 D. Okay, 501 101 J, 501 101 some. See, these are the course IDs. Okay, student name is suppose some 7. Student name is 7. Okay, course name is Java. Suppose he wanted to register. 7 wants to register all the 3 subjects. Okay, we can identify the fee. Okay, what about the course fee? Java fees is 1,000 rupees. Java fees is 1,000 rupees. Suppose DBMS fees is 800 rupees. CO fees is 600 rupees. Suppose we wanted to register for these 3 subjects. Based on the student ID and course ID only we can identify some subject fee. Okay, we don't know, based on the student number we cannot identify the subject fee. Okay, here in this example student ID and course ID is a prime attribute. Okay, student name, course name and exam fee is a non-prime attribute. I hope you are clear. Next, fully functional dependency. What is fully functional dependency? The non-key attributes. The non-key attributes are fully functional dependency on the, okay, if you want to know about the student name, Okay, based on the student number and student ID, we can identify the student name. Okay, suppose 7. Okay, 501 101. Okay, then we can identify his register for some Java course and fees is so and so. Okay, this is nothing but student ID and course name. Okay. Next, partially dependency. Partially dependency is nothing but any non-key attribute. If we wanted to identify, suppose I wanted to identify what is the fee of particular Java course. Okay, particular Java course. We cannot identify. Suppose by using the 501, we cannot identify the fee of the Java course. If we know the course, why? Because student number 501 501 501, he registered for around how many subjects? Okay, course name is Java, 7 is registered, course name is Java and DBMS, as well as he registered for CO also. Okay, suppose I want to know about whatever the course fee of some particular subject. Okay, if we know the course ID, then only we can identify. This is called as a partially dependence. Okay, partially dependence. Okay, that's why what is the second normal form? In the second normal form, all the values fully functionally depend upon the candidate key, means prime attribute. Okay, first of all, what are the rules for second normal form? A second normal form can be defined as a relationship said to be second normal form. First, it is a first normal form, and non-key attribute is fully functional depend upon a prime key attribute. I think I hope you are clear on the prime key attribute. Okay, prime key attribute is nothing but a candidate key, means more than one key. Okay, key 1 and key 2. Here we have a key 1 and key 2. The key, by using the candidate key, by using the two keys, you can identify the non-key attributes. Then that is called as a prime attribute. Okay, here in this example, okay, student ID, class name, course and time. Okay, student entity consists of student schema consists of student ID, class ID, name, course and time. Okay, student ID and class ID is prime key attribute. Okay, prime key attribute. A student can attend different courses in a different classes at different times. Okay, suppose if you take 502, okay, date, this is the date, day, time and date. Okay, some 1010. Okay, some October 10th. Okay, July 10th. 10th October, 7th October, 15th October, 8th October and 17th October. Okay, here student 123, 124, 125, 126. Okay, suppose 126 is registered for two courses, some 504 and 504. This is the course ID. 504, 505 is the course ID. Mehta is the name of the student. The Mehta is registered for here. Mehta is registered for two courses. What are those? 504 and 505. He is registered for two courses. This is the course ID. 460 and 461 is the course ID. Okay, what is second normal form? Second normal form is nothing but non-key attributes. What are the non-key attributes? Name, course ID and time. Okay, these values, non-key attributes, are fully functionally depend upon the course ID, means prime attribute. What are the prime attributes? These two are the prime attributes. Student ID and class ID is the prime attribute, but name, course ID and time, okay, these are the non-key prime attributes. These are fully functionally depend upon the prime attribute. Suppose if you take 123 502, Ravi. Okay, Ravi, he is registered for which course? Okay, 123 registered for which course? Once you know about the course ID, this is the student course ID, we can we know this is fee. I think 2 times this is a course ID. This is about the fee. This is the serial number. This is the roll number, student roll number. Okay, this is not course ID. 2 times. Okay, 502 student number. 502 is the course ID. Okay, Ravi, he is registered for so and so, and this is the 1 minute. Okay, please not consider this. Okay, student name, student ID, class ID, name, course ID and time, name. First of all, if you check Okay, student ID, class ID, name, course ID. Here student ID and course ID is the student ID and course ID. These both are the prime key attributes. Remaining class ID. Suppose if you know the student number, based on the student number, we can identify the class ID 502. Okay, and also we have to require he belongs to which course. Okay, why? Because each and every student have a different classes. Okay, suppose 302 in 312 in one class, 313 one class, 312 another class, 460 in another class, 461 is another class. Based on the class IDs, we have different course IDs. Each and every course conducted in the different classes. Okay. Okay, these two are the prime key attributes. These two are the prime key attributes. Okay, these two are the prime key attributes. This one. These two are the prime key attributes. Okay, compulsory all the non-key attributes is depend upon the only two values. But in this example, in the relationship, two students can same class. Two students are going for the same class. Okay, 502, 123 and 125 belongs to same class. Okay, whatever the course ID 312 and 312. Okay, and one student can attend for two different courses. Who's that? Okay, Mehta. Okay, his student is 126 and 126. Okay, 460 and 461. Okay, the name of the student can be determined by using the student ID. Therefore, non-key attribute name is functionally depend on a partial key. Okay, here in this example, we can identify the student name depend upon the only student ID only. Who is Mehta? Okay, 126. Okay, by using 461, 460. Okay, we have two courses. This particular student is registered for two courses. Okay, by using 120, 126 and 460, we cannot identify the Mehta. Why? Because Mehta has registered for two courses. Okay, here this is a partially functional depend upon the only one key attribute. Okay, actually what is the second normal form? Second normal form is nothing but a relationship. A relationship is non-key attribute is determined by using the prime attribute. Here these two, what we have to highlighting with the red color, those are the prime attribute. But here in this example, we can identify the student name by using only rule number only, student ID only. We cannot identify course name. Okay, if you know about the class ID, okay, class ID by using the 123 and 312, we can identify the class ID. But student name, we can represent the student name by using only student number. Okay, who is Ravi? 123. Who is Kumar? 124. Okay, who is Mahesh? 125. But remaining attribute, okay, time and date. What about the date of the particular course? Who is the student? Okay, these two attributes, class ID and date, two are representing by using course ID and student ID. But name is determined by using only student ID. Okay, this is not in the. It is partially depend on the only one attribute, one non-key attribute. That's why it is not in the second normal form. Okay, what is the second normal? Okay, that's why. Okay, what are the problems? Okay, if it is not in the second normal form, the name of the student is repeated every time. Okay, it maybe take different courses. The name of the student is updated, then entire row. Suppose here instead of Mehta Kumar or Mehta, okay, Royal Mehta, if you wanted to update his name, okay, that is a problem. Okay, the result of lossy of data integrity is relation will show different rows of the information. Suppose he is not updated his table, his values. Okay, if a student wants to register for more than one course, okay, Mehta wants to add one more course. Okay, then if we want to change his name, okay, automatically he wanted to update all the rows. Okay, suppose if we updated only one row, he's forgot to update remaining row. It is a problem. To overcome this problem, we dividing this particular table into two tables. We are decomposing into two tables. What are those? Student and student course. In the student, student ID, class ID and course ID. Okay, student ID, class ID and course ID and date. Okay, in the student table, okay, we are dividing student ID and name. Okay, this particularly we have a student and student ID. First we are dividing into student 1. Okay, student first is the student 123 is Ravi, 124 is Kumar, 125 is Mahesh, 126 is Mehta. Okay, first we have to dividing into student table. After that we go with the student course. In the student course, okay, 123 is registered, 124 is registered, 126 is registered, different courses. Okay, now if we have to change the name of the student, only here we have to do only Mehta Kumar. Okay, Mehta Rai. Okay, automatically once we change here, no problem, no data repetition. Okay, if we insertion anonymous also no problem, deletion also no problem. Okay, now this particular table in a second normal form. What is the second normal form? First it is in the first normal form. First normal form is nothing but no is each and every value atomic. Each and every row has a atomic value. Okay, each and every row. Okay, here is each and every has a atomic value. And also in the second normal form. Second normal form is nothing but the key attribute. Okay, suppose if you wanted to identify the class ID. Okay, this particular 502 is a class ID is depend upon the course ID and 123 rule number. Okay, it is now particularly in the second normal form. I hope you are understood about the second normal form. Okay, if you have any queries, please comment me. Okay, in the examination they are asking about, okay, they are giving one relationship, otherwise they are giving some dependency. Okay, they are giving like that table. Okay, can you explain about the functional dependency of this particular table? Functional dependency is nothing but write a functional dependency of the particular table. Okay, we have to write like this. Okay, student number. Okay, we have to write like this. Okay, functional dependency of the particular table we have to write. Okay, SSN number means some social security number. Okay, depend upon the hours and project number. Okay, functional dependency 2. Okay, social security number depend upon employee name. Functional dependency 3. Okay, social security number and employee number depend upon the project name and project location. First we wanted to write the functional dependency. Functional dependency is nothing but key attribute is, okay, we determine the particular attribute, particular column, okay, by using, suppose for example in our previous example, okay, suppose if you wanted to know about the student name, okay, student name, okay, what are the functional dependencies? Student ID is functionally, okay, student name is functionally depend upon student number. Okay, course ID, okay, if student ID and course ID and course ID, course name is depend upon the both. Course ID is, course name is depend upon these things. Okay, course fee is also depend upon, CID is depend upon some exam fee. Okay, like that, these are called as a functional dependency. Okay, first in the examination in MCQs they are giving, okay, one relation, write the functional dependencies, and also write a transitive dependency, write a partial attribute dependency. What is the transitive dependency? Like that. Okay, first, then we go with the third normal form. What is the third normal form? A relationship in a third normal form. First, it is the second normal form, and there is no transitive functional dependency. What is transitive functional dependency? A functional dependency x to z. Okay, z is functionally dependent upon x, that can be derived from two functional dependencies, x to y and y to z. When a table 1 functionally depend upon the table 2 and table 2 is functionally depend upon the table 2, then table 3 is transitive depend upon table 1 via table 2. Means we can identify a non-key attribute by using x to y, y to z. Okay, in this example, suppose in a table employee number, salary slip, employee name and salary. Okay, here based on the employee number, in the above table employee number is determined based on the salary slip. Okay, on the salary slip we know the employee number. Okay, we have no employee name on the salary slip, only we have a employee salary slip as well as employee number. Okay, first if you want to identify the name of the Amit, first of all we go with the salary slip. Salary slip depend upon the employee number determine the employee name. Okay, this is called as a transitive dependency. Okay, there is no transitive dependency on the employee name. Therefore employee number is determined employee name. We have transitive functional dependency so that the structure not in the satisfy the third normal form. Why? Because here salary slip, if you want to know about the some employee salary, first of all first we know about the salary slip. Salary slip is depend upon the employee number is depend upon the employee name. Okay, so this is called as a transitive dependency. Okay, if a relationship in the third normal form, first it is in the second normal form. Okay, it is in second normal form. Why? Because employee number is determined all the key values and also atomic values. Okay, that's why it is second normal form. But this is not third normal form. It have some transitive dependency. Okay, salary slip is determined employee number is determined employee name. Okay, why? Because each and every non-key attribute is determined by the only key attribute. But here I want to know about the salary of Amit. Okay, first of all we know about the salary slip. Okay, salary slip number. By using the salary slip number I identify the employee number. Based on the employee number I want to know Divya's salary. Okay, this is in the transitive dependency. To overcome this problem we dividing in the table into two tables, employee table and the salary table. Okay, suppose what about the salary of Divya? Okay, from using this table, okay, first what is the name of what is salary slip? Okay, 101, employee number 101 Amit. Then 101, what about the salary? 50. Now easily employee number, salary slip number is 1 Amit. Okay, then based on this we can identify. Why? Because here there is no transitive dependency, we cannot identify. Okay, in the previous, okay, if you wanted to identify, first we know salary slip, this is X, this is Y, this is Z. Okay, Z, okay, this is X is identified by Z based on the Y only. Okay, this is in not this is called as a transitive dependency. To overcome this problem we go with the transitive dependency. Okay, please check over. Okay, when they have to give a I think around on the normal form, first normal form, second normal form, third normal form, they are giving around minimum 1 question, maximum 2 questions. Basically they are concentrated on the functional dependencies only, relationships only. Okay, please remember we have a transitive dependency, functional dependency, prime attribute dependency, non-prime attribute dependencies. Okay, here prime attribute dependency, non-prime attribute dependency, fully functional dependency, partial dependency and transitive dependency. Total we have a 5 dependencies. Okay, once again I will repeat. Prime attribute dependency. Prime attribute is nothing but in the relationship we have a candidate key, then that is called as a prime attribute dependency. Non-prime attribute means if a particular key is a not part of a prime attribute, then that is called as a non-prime attribute. Okay, fully functional dependency. Fully functional dependency is nothing but key attribute is fully. Okay, in a relationship the key attribute is determine the non-key attributes, then that is called as a fully functional dependency. Okay, suppose in this example, okay, social security number can identify remaining all the values, then that is called as a fully functional dependency. What is partial functional dependency? For partial functional dependency is nothing but in some examples we have prime attribute. Okay, some non-key attributes depend upon the determine the any one of the candidate key, that is called as a partial dependency. Okay, that's why if we have a partial dependency we go with the second normal form, we have a transitive dependency we go with the third normal form. Okay, once they are giving the table you try to write like this. Okay, you have to write all the functional dependencies, then we know about all the dependencies. Okay, thank you watching my videos. Please subscribe Easy BTech channel. If you have any queries please comment me in comment box. I will give suggestions. Okay, if you I think already we completed all the concepts from introduction to DBMS to normalization. Please go through all my videos. I wish you all the best for your examination. Thank you.